Okay guys, we're back at it and we're going to continue with our discussion of dot products. So we're still in lesson 8.08, but this is day 2. Now, what we're considering today is, does the order or location of a scalar multiplier matter? So what we're asking is, if I have matrix A and I do a dot product with a scalar multiplier k times b, is that the same thing as if I put the scalar multiplier k with the a first? Or could I do a dot b and then apply the scalar multiplier? So we want to see, does the order or location of that scalar multiplier matter? So let's tackle the first one first, but we need some matrices to work with. So I'm going to say that A equals 1 row, 3 columns, 1, 0, 2. B equals, it's got to be the same size, so it's 1, negative 2, 2. And I'll use a scalar multiplier of k equal to k. So let's tackle the first one. Let's go A dot KB. And let's see what that equals, okay? So we've got, it's a big dot. We've got 1, 0, 2 dot k times 1, negative 2, 2. Okay, so we're going to distribute the k into the matrix. So that is 1, 0, 2 dot k times 1 is k. K times negative 2 is negative 2k. And k times 2 is 2k. Then we're going to do the dot product of those. So we've got 1 times k plus 0 times negative 2k plus 2 times 2k, which equals k plus 0 times the negative 2k, that's 0, and we've got 4k, which equals 5k. All right, so that's the first one. Now let's see what ka dot b is. So we've got ka dot b, which equals k times the matrix 1, 0, 2 dot the matrix 1, negative 2, 2. So now we've got the matrix k, 0, and 2k. Now I want to notice, I had to put the 0 in there so that I maintained that the two matrices were equal in length. Now we're going dot 1, negative 2, 2. So this has the same number of entries as that does, and that's still important. So now we're going to do the dot product here, and k times 1 is k, plus 0 times negative 2 is 0, plus 2k times 2 is 4k. Guess what? Equals 5k. So far everything's looking good. Now what we're going to do is we're going to do the dot product of a and b first, and then apply the multiplier. So we've got k parenthesis a dot b gives me k. And now we've got the matrix 1, 0, 2 dot 1, negative 2, 2. So that is k outside of 1 times 1. You want me to do the arithmetic, or I should do it? 1 times 1 plus 0 times negative 2 plus 2 times 2. So that's k times 1 plus 0 plus 4, which equals k times 5, which equals 5k. So what we've just shown is that the location of a scalar multiplier doesn't matter. We can move it around. So sometimes when you're doing operations, you might want to do the dot product first and then multiply, or you might see that applying that scalar multiplier to either matrix first would be easy, and so you tackle it that way. But anyway, we can say that order slash location of scalar multiplier doesn't matter. All right, let's go on to the next page. What we're going to do now is we're going to take a look at, do dot products follow the rules of binomial multiplication? Wow, okay, so first off, a lot of you have never had binomial multiplication. You don't know what that is. So what we have to do is I have to show you first what binomial multiplication is. So I've got x plus y times x plus y. Now these are known as binomials because there are two terms here and two terms here. Just like a bicycle has two wheels, a binomial has two parts to the expression, okay? Two terms. What we do is we just use distributive properties. So I'm going to take x plus y and I'm going to distribute it to the x and to the y. So this gives me x plus y times x plus y times y. Now, I'm going to distribute again. This time I'm going to distribute a single x in and then a single y in. Okay, so now we've got x times x plus x times y plus x times y plus y times y. And if I reduce this down, that gives me x squared plus 2xy. See, there are 2xy terms in addition, so that's 2xy plus y squared. Now, I know some of you do know binomial multiplication and you're aware of the FOIL method. Don't worry, you're going to get a lot of practice in binomial multiplication next year. But I had to show you this so we could actually answer this question. Now, on the side, there's also something known as the area model. So I'm going to draw a square here. Oh, that was terribly done, but okay, bear with me. And I'm going to divide it up into 4 boxes, okay? And I have x plus y here and x plus y there. Now, the area of this square is x by x, or x squared. The area of this box is x times y. The area of this box is also x times y. And the area of this box is y times y, or y squared. And if you add all those up, x squared plus 2xy plus y squared. Okay? So that is just a brief, oh my goodness, really brief introduction to binomial multiplication. So we're going to take this and start applying it in the next few examples. I'm going to pause the video.